Julia sets for my final presentation for Intro to Numerical by Dr. Potter. And so, we'll wait for this to load. Let's get started. Well, Julia set. This came about in around 1915 by a French mathematician named Gustin. And up to the right, we have a picture of him. And yes, that is a violin. The field in Julia's set of a complex number C is a set of all z for which the iteration f of z equals z squared plus z does not diverge to infinity. For almost all complex numbers C, these sets are fractals. The dichotom theory. This theory states that there are only two types of Julia sets. This is a consequence of a theorem provided in 1918 by Pereire, Fatto, Gustin, and Julia. And for these, first we define the field in Julia set Kc for each complex number C, as I stated before. For each point z0 of the plane, we generate a sequence z1, z2, z3, so on and so forth. By the basic iteration rule is zn plus 1 equals zn2 plus c. If the sequence does not run away to infinity, then the point z0 belongs to Kc. If the sequence does run away to infinity, then z0 does not belong to Kc. First, we note the three computational aspects of the definition Kc. And so, right here we have this picture, and then the one to the right is two magnifications, and as we can tell, the black dot is getting bigger, because in the end, you can't really tell, but all these dots are connected. My code. So, my code, I'm using a Julia fractal set, and I created a Sun 2D by setting n to 100. And from our winter fractal, I made a Mandelbrot set, and by using n at 1,000, it allowed me to create this. So now, I'm going to show you how this works. Let me just... sorry about that, hold on. There we go. Sorry, it's a little slow. Get out of there. All right. So first, I'll start off with my winter fractal. This function creates a Julia set fractal in the n number of points that the user can specify. And so that's our function in n input, positive integer of endpoints if n is greater than 0. And so introducing the variable parameters is what you see below. And now, this is creating row vectors with evenly spaced endpoints between Cx minus 1 and Cx plus 1. This creating new row vectors with evenly spaced endpoints between Cy minus 1 and Cy plus 1. This replicates the grid vectors x and y to produce a full grid. This grid is represented by the output coordinate arrays x and y. This, by defining function c, you get negative 0.55 plus 0.6 times 1i. And defining the function z, we get that code. And counting iterations from 1 to my variable column. And this is creating a new function of z for the iterations 1 to my variable column. And that's the end of that. And so using the color map winter function of value of 45, we then end up with that. And varies the color in each line segment and face by interpolating the color map index or true color value across the line or face. As you can see, okay, for this one, displays the following if the user inputs a value less than or equal to n, else if n is greater than or equal to 0. Error, please do not input a positive integer for n. And so now I will run this and say if I put in 10, I'll press run. And it'll come up with that. And when n gets bigger, so say I'll put in 50, you can tell the shape starts to blow up a little bit more. And then now when we put in 100, you get our little snowflake. And now, if we try 1,000, let's see what we get. And it's busy. And boom. Merry Christmas. That's what I like to see. All right. Now for my next one, my Sun 2D. This function creates a Mandelbrot set fractal in the n number of in the n number of the iterations that the user can specify. Excuse me. So introducing the variable parameters as you see right here. And now, first up, you start with creating row vectors with evenly spaced endpoints between x1 minus 1 and x1 plus 1. Now, by creating row vectors with evenly spaced endpoints between y2 minus 1 and y2 plus 1. This replicates the grid vectors x and y to produce a full grid. Excuse me, this grid is represented by the output coordinate arrays x and y. By defining the function z and defining the function c, this continues iteration from 1 with a variable column. And again, using the color map hop function as a value 256, this varies the colors in each line segment and face by interpolating the color map index or true color value across the line or face, as you see. And by displaying the following, if the user inputs a value less than or equal to 0, then the error, and also if we cannot input a positive integer for n. Sorry about that. And so, please input an integer for n. I apologize. So I'm going to run this. Save for 10 again. It's a little blurry. So now let's see what happens when I type in 100 or 50 or 100. I get this, which is pretty nice. And then now let's try 50 again. As you can see, the bigger the number, the clearer picture you get. And now 500, let's see what happens. And I'm waiting. And boom. So, that's my project, and I hope you enjoyed. And